Today's forecast calls for the mother of all storms. A maelstrom of rocky debris, followed by searing 575-degree temperatures, hyper-hurricane winds, 600-foot-high tsunamis, and thick clouds of acid rain. This is the weather for the day a giant space rock hits planet Earth.
You would have hot debris coming from the impact site, setting off firestorms.
It has happened before, and it can happen again.
No place on Earth is safe when one of these giant rocks hits.
An impact of that scale may mean the extinction of the human species.
Take cover as we prepare you for the single greatest natural disaster to threaten Earth. Earth's is just one kind of weather. On other planets, there are storms beyond the imagination, climates and conditions that we hope to never see on Earth. But could they happen here? And if so, could we survive? Deadliest space weather. Los Angeles, California. It looks like a picture-perfect day. Not a cloud in sight. But the forecast quickly turns deadly. A gigantic rock plunges from space hundreds of times faster than a speeding bullet. It punched through the Earth's atmosphere and struck the ground with the energy of 20 million tons of TNT. The metropolitan area of Los Angeles is completely obliterated. And the destruction is far from over. Seconds later, and 360 miles to the north, a fireball of hot vapor and debris reaches San Francisco, followed by a massive earthquake. Another city is in near ruins. The aftermath of the cosmic impact is felt across the entire United States. Soot travels thousands of miles and covers places as far as New York. This is not an actual event, but it could be if Earth is struck by a large meteor, one of the deadliest types of space weather.
To think of meteors as a form of weather, or at least contributing to weather and climate, is actually quite appropriate. The forecast is continuous rain of rock and ice with occasional showers, right? So it's almost a weather phenomenon.
To understand their threat, we must look into the past. Meteors are among the most frightening forces of nature. For billions of years, they've triggered the worst weather imaginable and are predicted to do so again in the future. Today, most of these rocky remains from the formation of our solar system lurk in the asteroid belt between Jupiter and Mars. But occasionally, one gets jostled out and heads on a collision course with Earth. While in space, a rock is called a meteoroid. But when one passes through the Earth's atmosphere, the impact pressure causes it to heat up and form a fireball known as a meteor. Our planet's thick atmosphere acts as a protective blanket and vaporizes most meteors. But rocks occasionally slip through. When they strike our planet, they become meteorites. And these mysterious chunks of rock and metal can wreak havoc on our climate.
Meteors can cause severe heating in the atmosphere. They will loft dust into the atmosphere for long periods of time. So at least on the short term, it can have some very severe weather impacts, and over the long term, potentially climate as well.
Since the formation of the solar system, Earth and other inner planets have been pummeled by millions of space rocks. Today, less than 200 impact craters remain visible on Earth. Our weather, such as wind, rain, and snow, has erased most of our violent history. But we can count the craters on our nearby moon to estimate how many times our planet was also hit in the past.
On the moon, you've got no atmosphere, you've got no weather, you've got no erosion. You're looking at the cratering history just by looking at its surface.
On Earth, we're continually reminded that meteorites pose a serious threat. Over the last few decades, amateur video has even captured space rocks crashing into Earth. In 1992, a fireball streaked across the night sky and finally smashed into a car in Peekskill, New York. And every few hundred years, larger meteorites known as asteroids can impact our planet and affect us in a big way.
The result of a meteor impact depends on how much energy is in the meteor when it comes in. Very large ones, very fast ones, very dense ones deposit a lot of energy.
Astronomer Michael Mishna explores the deadly potential of different types of meteorites by dropping spheres of various sizes and densities into a pile of sand to demonstrate the craters they produce.
Whoa! Whoa! Look at that! All right, let's go see what damage we did. All right, let's see what we got here. Oh, this looks great.
The crater from the small, dense steel ball is not much bigger than the ball itself. The bowling ball makes a more impressive impact.
The size of the crater that it produced is quite a bit larger than the ball itself, and that's typically what we expect. Craters that come in from space are generally 10 to 20 times the size of the impactor themselves. As we move to the largest of the balls we had here, the medicine ball, the damage that it did was much more significant than the others. The size of the crater is many, many times larger than the impactor itself, and it's also quite a bit deeper. That's because this medicine ball is very, very dense. If we were to take something like this medicine ball and blow it up in size to maybe 1 to 2 miles in diameter, the impactor would create a crater that was large enough to destroy an entire city.
Extraterrestrial rocks can do more than form craters or level a city. They can ignite a climate disaster beyond human imagination. Earth has endured some extreme disasters: hurricanes, earthquakes, tsunamis, forest fires. But imagine all these disasters happening all at once, all across the globe. Scientists think that about every 100 million years, Earth is struck by an asteroid massive enough to trigger such an apocalyptic storm. The one that wiped out the dinosaurs hit 65 million years ago. So how much time does that leave us? $65 million years ago, Earth experienced a death blow. Most scientists believe a Mount Everest-sized rock slammed into the ocean off the Yucatan Peninsula with the energy of a 100 million megaton bomb.
That veneer of water was kicked up into a pretty significant tsunami, which we know washed inland for tens, if not hundreds of miles along the Gulf Coast, because in the fossil deposits that we see in the Gulf of Mexico today off the shore of Texas, we can see the ripped up sediments that have been carried out into the Gulf of Mexico from far inland.
As killer waves drowned the shorelines, the meteorite impact also ejected rocky debris from the ocean floor, which blasted into the atmosphere and rained back down. The surface of the Earth was suddenly heated to the temperature of a broiling oven. A dark cloud of dust and vaporized rock filled the atmosphere. producing acid rain as toxic as battery acid.
These materials contain substantial amounts of sulfur. That sulfur, when distributed through the atmosphere, creates aerosols, which heat the upper atmosphere, cool the lower atmosphere. That affects the climate.
So Earth went from very hot temperatures to then cooling to well below what the climate had been.
And most importantly, the dust kicked up would block so much sunlight that plants and algae wouldn't be able to photosynthesize. The whole food chain would be broken apart.
The far-sweeping disaster lasted for thousands of years. In the end, 75% of Earth's largest species, including the dinosaurs, were stoned, scorched, or starved into extinction.
What dinosaur ruled North America at that time? The Tyrannosaurus. What happened to them? They were probably barbecued by the impact crater.
If the same sized asteroid were to strike again today, humans might also go the way of T-Rex.
If an impact of that scale were to happen on the Yucatan today, we're talking hurricane-force winds that would blast out for 1,000 miles in every direction.
Tidal waves would just inundate all the coastal regions.
2 hours after an impact in the Yucatan, and 1,500 miles to the north, a thermal air blast would reach New York City.
This fusillade of debris carried by the blast from the impact will pepper you, almost like a shotgun blast. That alone would be fatal. The heating in the atmosphere from that shock would be enough to ignite newspapers and dry leaves. The scorching effects followed by the blast, blowing out windows. Structures like the Brooklyn Bridge and other older structures in a city like New York would be damaged, if not destroyed.
And the wrath of the killer asteroid would not stop there.
Forest fires would break out all over the place. You'd have all this acid rain coming down. You'd have highly elevated surface temperatures.
Even in today's modern world, an impact of that scale may mean the extinction of the human species.
The next Armageddon asteroid isn't estimated to impact Earth for another 35 million years. But this is merely a rough estimate.
The last mass extinction was 65 million years ago. So one might think that we're safe for a few more tens of millions of years. But really, these things don't come in a periodic way. So there's some concern that this will happen in the relatively near future.
A mass extinction-sized asteroid will probably strike Earth again. But humans need to be more worried about the thousands of smaller rocks. Ones that can mess up our atmosphere, climate, and geography without ever touching the ground. $65 million years ago, a mountain-sized asteroid may have caused a global climate catastrophe that led to a mass extinction on Earth. But much smaller rocks can also strike a colossal blow. Just 100 years ago, our planet had a celestial close encounter of a different kind. On June 30th, 1908, an explosion erupted above Siberia's remote Tunguska wilderness. The fiery blast bulldozed and burned 80 million trees in the forest, 3 times the area of New York City. The Tunguska disaster remained a mystery for decades. No crater or meteorite fragments were ever found. Wild speculations surfaced, even rumors that it was an alien attack. But in 1945, the atomic blast over Hiroshima finally provided startling clues. Scientists figured out that smaller space rocks could explode in the atmosphere, much like a nuclear bomb.
That's enough force to actually shatter and break that object, so it doesn't even make it to the surface of the ground. That energy is deposited in the atmosphere. It's something the equivalent of the blast that you'd get from a small nuclear weapon.
Scientists now think a meteoroid, roughly half the size of a football field, smacked into the atmosphere above the Siberian forest. The meteor itself was pulverized when striking the atmosphere, but an explosive blast wave moved downward and rolled across the tundra, scorching almost 1,000 square miles of forest.
The shock wave and the wind that results from an impact dwarfs the biggest storms that we see here on Earth.
We see no crater. All we see is trees that have been flattened as if a gigantic hand from outer space pushed down on the forest, flattening trees in all directions.
Luckily, the area where the disaster struck was sparsely populated, so nobody was killed. The Tunguska disaster is thought to be the largest meteoroid impact in recorded human history. But if the same size rock exploded over a populated city, humans may not be able to weather the storm.
First of all, the infrared heat radiation would be enough to fry and boil most objects on the surface of the ground. Then the shock wave actually hits a fraction of a second later. It would topple buildings.
Imagine a Tunguska-sized meteoroid exploding over San Francisco. The Transamerica Pyramid, the city's iconic skyscraper, has a wide base that narrows by each floor, along with diagonal trusses to increase stability against horizontal and vertical forces. But even it would cave to the force of an airburst impact.
The Transamerica building, with all that glass making up the windows and the sides of the buildings, that would all be blown out due to the shock wave that was generated by the impact. The building might survive, but with significant structural damage, concrete being snapped or broken, bits of steel being bent or deformed. Because it's an incredibly strong explosion.
A Tunguska-sized meteor is estimated to impact Earth's atmosphere roughly every 100 years on average. So the century-old disaster in Siberia serves as a wake-up call. Scientists are now racing against the clock to develop technologies to defend us against the next cosmic firestorm. Earth is destined to experience another asteroid attack. One that could cause a natural disaster of epic proportions. With so much at stake, NASA is keeping special tabs on nearly 5,000 potentially hazardous asteroids. These space rocks are bigger than a football field and estimated to come within 5 million miles of Earth. NASA has listed their risk of impact on a website, much like an early warning system for tsunamis, tornadoes, and hurricanes.
A fraction of them have orbits that cross the Earth's orbit, and eventually it will cross Earth's orbit when Earth is there, and we will be hit by Earth-crossing asteroids. It's happened in the past, it will happen again in the future.
Since the surface of our planet is about 75% water, an asteroid is more likely to land in an ocean. But that's not necessarily a good thing. An asteroid impact could trigger waves about 30 times higher than the tsunami disasters in Japan and Indonesia.
If you hit in the ocean, you create these mega tsunamis that obliterate the coastal regions. We've even seen this when gigantic earthquakes have occurred on Earth. Much of the damage has been from the tsunami, not from the rumbling around of the Earth's crust.
Earth cannot defy the impact odds forever. So special technologies are being developed to prevent a cosmic collision.
My favorite is what we call the gravity tractor. We simply park a spacecraft next to the asteroid, use the mutual gravity between the spacecraft and the asteroid to tow and tug the asteroid slowly off course over time, causing it to miss the Earth.
Like any natural disaster, the key to mounting a counterattack is lead time, which could take years or decades. And there are millions of hazardous asteroids that have not yet been detected.
We should be developing the technologies now to go to asteroids, understand their makeup, understand what it takes to deflect them, so we can prevent a catastrophic collision in the future.
The future of our planet is far from safe. If we don't heed the warnings, a cosmic rock could become the space weather that ultimately snuffs out the human race.